So we talk about business case drivers for hybrid. One of the, really pillars of making a business case is to basically reduce the amount of material that's used. So instead of starting out with a large volume of material, billet, whatever your raw material is, and then machining it all the way down, we can start with a minimum build plate, which ideally is used as part of the part, print the near net shape, and then machine to the final dimensions. So only machining a fraction amount of the material away compared to basically starting out with a larger piece of billet. We can do repair with a hybrid machine. A hybrid machine really gives us the capability to take a damaged part, load it in the machine tool, machine away that damaged area, print on that surface that was established with the machine tool, and then remachine that area back to final spec. Also, because we're using commercially available welding wire, you don't have to have every kind of infinite amount of stock size for material in a shop. You just need to have that particular welding wire, and you use the system to print that net shape.
Yeah, so I'll cover the first couple of points here. So this question comes up a lot when you look at the hybrid manufacturing, because it's, okay, well, what's the opportunity space? And the first thing to note, and is seldom mentioned, but it's a very sustainable process, because first you're building the part up rather than subtracting, creating your part from a subtractive process. So in a lot of cases, and we've got some applications we can show you, you use a tiny fraction of the material that you would otherwise use in a subtractive process. So it's very sustainable from that perspective. Also, from a 3D printing perspective, laser wire is optimized, fully optimized, because all of the material goes into the part. Unlike, for example, in a powder blown process where only a fraction of the material ends up in the part. So it's very sustainable on materials. It's also very sustainable on energy consumption. Laser systems are incredibly efficient. You create these very compact heat affected zones. And so you just put in the heat where you need it. And laser systems are approximately 45–50% energy efficient. So this electro-optical efficiency is extremely high. So it ticks a lot of boxes on the sustainability side. The other thing it's going to give you is this production flexibility. Because with a 3D printing tool, you can change your plans, change your strategies almost on the fly. And then also be very flexible on whether you're just doing a one-off part or whether you're doing a series production in a batch capacity. And again, from a 3D printing perspective, there's almost no cost penalty from doing one-offs to doing series production. So yeah, it's very flexible.
So also talking about the overall higher quality output, if you're taking a manual welding process to repair a part, now we're using the actual machine tool to deposit or weld that area up. You're taking out the human element. The machine is always going to repeat. And let's say you needed to add more material. We simply can add additional tool path to build up that current section even more. So you're really standardizing the repair process by using the machine rather than a manual welding process. Also, we can reduce the response time when you talk about providing quotes or actually just processing parts in general. We don't have to rely on particular pieces of material. It's simply, do we have the welding wire? And then we start building the parts, and you can give accurate time studies based on the slice time out of the CAM software, and then also overall time to process the part is going to be greatly reduced.